Okay, so what we're going to do now is we're going to use the fundamental theorem of calculus. Remember, there are two parts, and depending on your book, one is part one, the other one is part two, and then some books change it up. It doesn't really matter, but there are two parts. One is to find the antiderivative, the other one's to find the derivative. And so, but let's say we're trying to, so let's say for example you have a function. This is the integral from, let's say, 3 to x of, let's do cosine of t dt. And let's say the question is to find f prime at x. Okay, now, well, you might be saying, okay, well, I know how to do this. I can find the I can evaluate the integral and then find the derivative of it, right? So okay, that would be one way. So let's say we want to evaluate the integral. So here we're going to, so we'll call this the slow way. Slow way, and sometimes not possible. And we'll see why in a little bit. So first we're going to evaluate the integral, and the second thing is we're going to find the derivative. Okay, so the integral from 3 to x of cosine of t dt, well, this is just equal to, well, the antiderivative of cosine, that's just sine of t. And then we're going to evaluate this from 3 to x. Okay, and then if we do top minus bottom, so this is capital F of x, right? So what we're going to get is that capital F of x is equal to sine of, plug in top, which is x, minus plug in the bottom, which is 3. And so this is my function. And well, I can get the derivative of this. F prime at x is simply going to be, the derivative of sine is cosine of x. And the derivative of sine of 3, well, sine of 3 is just a constant. It's a number. I don't actually know how to find it without a calculator. But that's not the issue, is that the derivative of a constant is just 0, so the derivative is just cosine of x. Okay. Now, that's the slow way. Now, the fast way is going to be using the fundamental theorem of calculus. Now, I call it part 2. But your book might call it part 1. But it's basically the one that shows you how to find the derivative of an integral. And if I put it into words, the first thing is to make sure you have a constant on bottom, and function on top. Step 2 is, so as long as this is satisfied, all I have to do is plug in the function into the variable, plug in, that's not a good way to say it. Okay, so before I put it into words, I think what I'm going to do is I'm going to do it at the same time as I write down the steps. Now, so what I'm doing is I'm finding the derivative. So what the fundamental theorem of calculus tells you is as long as it's going from a constant to a function on top, in this case just x. Now in a little bit we're going to do ones that aren't just x, which are actual functions. But so what we're going to do is we're going to plug in top function, which is just usually just x, into variable inside of integral, whatever variable you are integrating with respect to. So what this basically says is just plug in x into the function that you have inside, and so what you would get is cosine of x. And that's going to be the derivative. Notice that's exactly what I found here, but with much less fanfare. I mean, I basically did nothing, you know. That's just what it is, and this always works. Now, now the next thing is, well, that's okay, but if, now here this is just an if. Now, in this case it doesn't matter, but in a little bit we're going to do an example where it does, is that if the top function is not just x, then use the chain rule. Okay, so we're not going to do it this way anymore. This is the long way. And I'm going to show you why. I'm going to do an example where you can't even do it this way, even if you wanted to. And we're just going to use the fundamental theorem of calculus. So let's say you're trying to find, I'm just going to do a small modification. I'm going to change it from 3 to x of sine of t squared dt. Now notice that you can't even do this the slow way. So the question is to find the derivative, f prime of x. We can't even do this the slow way. Even if we wanted to, we can't do this the slow way. We're looking at an integral that we don't know how to find the antiderivative of. Because here, if it was just sine of t, that I would be able to do. Sine of t squared, not happening. And not even using substitution, which you're going to learn in a little bit, you can't even do that with this one. So, but you can use the fundamental theorem of calculus. The fundamental theorem of calculus tells you, okay, you want to find the derivative of this integral. First, check 1. Do you have a constant on the bottom? Check. 3. Any constant, doesn't matter. Do you have a function on top? X. Yes. Fundamental theorem of calculus says just plug it in. So what I'm going to have is the derivative of this function is equal to sine of, instead of t, I'm going to put x, so sine of x squared. And that's it. We're done. Finished. Now let's say, easy, right? I mean, that's it. Okay, now here's another example. So we're going to do another change. Let's say that f of x is equal to the integral from 3 to 2x of the same function, sine of t squared dt. And the question is find f prime of x. Now here you do the same thing. Your basic checks. First, is there a constant on the bottom? Yes, 3. Function on top? Yes, 2x. Okay? But now, it's not just x, it's 2x. So this is a function that's not just x, and if you remember back to this guy, if the top function is not just x, we have to use the chain rule. So, in the chain rule, see, this guy is my inside function. You imagine that as your inside function. So the chain rule says, okay, get the derivative of the outside, which is the first part of the fundamental theorem, which tells you, okay, just plug in this guy. So we're going to have sine of not x squared, but sine of 2x squared. And then after you do that, multiply it by the derivative of the inside. Well, the derivative of the inside, well, that's just 2. So here, this is nothing more than the chain rule. This is derivative of outside and derivative of the inside. That's the chain rule. And that's it. Well, that's good. But now, what if we get kind of crazy here and we have the integral? Oh, terrible, terrible. Okay. So we have this function. The integral from x to 5 of the same thing. Let's just keep it the same and see how it changes. And the question is to find g prime of x. Okay, now this doesn't pass my first check. My first check says, do I have a constant on bottom, variable on top? Well, no. No constant on bottom, no variable on top. These are flipped. Aha, but what I can do, remember you have your properties, you can switch the limits of integration as long as you change the sign on the outside. So this is equal to negative the integral from 5 to x of sine of t squared dt. Okay, and now this passes my check, right? Because I have constant on bottom, function on top. It's just x, so this is easy, easy peasy. This is negative. The negative is just this one on the outside. Fundamental theorem of calculus says, find the derivative, just plug in x. So I'm going to have negative sine of x squared. That's it. I'm done. Wow. It's only been like 3 minutes and we did 3 problems. Easy, easy, easy. Okay, now let's take a look here. What if we have instead of finding the derivative of the function, what if we want to find the integral from 3 to x of the derivative with respect to t of sine of t squared dt. Aha, now notice that here the derivative is on the inside of the integral, whereas here you could think of this as being on the outside. Well, this is actually slightly different. And you might be thinking, but I don't know how to find the antiderivative of this. Well, that's not asking you to find the antiderivative of sine of t squared. It's asking you for the antiderivative of the derivative of sine of t squared. Well, okay. Let's say you get the derivative of sine of t squared. You can find it, that's no problem. But then this is asking you to find the antiderivative of that. So you find the derivative, then it asks you for the antiderivative. Well, that means you just end up where you started. Exactly where you started. And you can test this, but I mean, this says find the derivative, then find the antiderivative. You're just ending up with the original function that you had evaluated from 3 to x, right? And so then here, this is equal to sine of, plug in the top, minus, plug in the bottom, and we notice that when the derivative is on the inside, this is different than what I had up here. So this is an important distinction, is that these two problems are not the same thing. Here you're asking to find the derivative of the entire integral, whereas here the derivative is on the inside. So you find the derivative first, then you find the antiderivative, and you still have to plug in the top minus the bottom. So these are different problems. Very important. Very, very, very important. Okay, now, for our last problem, we're going to find the derivative of, so we're going to use the fundamental theorem of calculus on a function that has functions on both the bottom and the top integral. And this is going to go from sine of, so the same one, we're going to do sine of t squared dt. Okay. So here, well, this doesn't pass any of my checks, right? Because I don't have a constant on bottom. I have a function on top, but I don't have a constant on bottom, so I can't do it. So the first thing we're going to do, you guys remember this little guy, right? Hold on, let me find him. Whoa. Right here. What did this guy tell you? Break it up, yeah. Okay, so this is what we need to do. What our little red guy recommended. Said break it up. Well, here we can break this guy up into two integrals. We're going to go from square root of x to, let's just say 0. It doesn't really matter because the constant doesn't matter when I'm finding the derivative. Of sine of t squared dt plus the integral from 0 to x squared of sine of t dt. Okay, so that's good. I mean, this is technically, well, I guess maybe we shouldn't pick 0 just because, well, square root of x isn't really defined for values less than 0. So maybe we should pick, I don't know, 4? Sound good? 4? It'll still work, but it's technically it might lead to some problems. Okay, now, so anyways, but that's fine. Now, this one, notice that it's okay, but this one isn't because we don't have a constant on bottom. But that's not really that big of a problem. I mean, we can just change that. We've done this before. We can change the limits of integration as long as we take a negative sign out. Okay. And now we're good to go. Now this looks like an intimidating problem, but it's not too bad. Let's just work through it the same way that we would the other ones. So here we're going to find the derivative using the fundamental theorem of calculus. And so the first thing this says is plug in. So as long as you have a constant on bottom, function on top, plug in your top function. So we're going to have minus sine of, instead of t squared, it's going to be, let me do it in green, square root of x squared. Aha, but then I have to multiply, since it's not just x, it's square root of x, I have to multiply by the derivative of the inside. The derivative of square root of x is 1 over 2 square root of x. So that's the derivative of this part. Now, plus the same thing for this one. The derivative of this guy, constant on bottom, function on top. First part says plug in. Let's do this one with purple. Plug in. Ooh, I just realized I missed the squared on this guy. Oh, and on this one too. Oh my goodness. Sorry about that. Didn't mean to do that. Okay, so I'm going to plug in the x squared. And then this guy is going to be squared. And then times the derivative of the inside, which is 2x. And that's it. Done. Woohoo! Happy, happy, happy. And that's the fundamental theorem of calculus for me, part 2. For some books, part 1. Doesn't matter. This guy's happy and he has a colorful mustache. And that's it. Goodbye.